today's problem from JEE Main PYQ, right? And this is from the differential calculus and from the chapter maximum and minimum. Very simple, interesting problem. Let small k and capital K be the minimum and maximum value of the function. This is given by fx, which is 1 plus x to the power 0.6 by 1 plus x to the power 0.6 in 0, 1 respectively. Then the order pair small k comma capital K is equal to. That is, we have to find the minimum value of this and maximum value of this. Okay, then we can write easily the order pair. To find the maximum or minimum value, we first differentiate the given function with respect to x, and we differentiate it by using the rule u by v. Okay, so the derivative of this is given by f dash x, which is 1 by 1 plus x raised to the power 0.6 whole square, and this is 1 plus x raised to 0.6 into the derivative of this. This is 0.6 into 1 plus x to the power 0.6 minus 1. This is the first term, and the second term is this term remains fixed, 1 plus x raised to the power 0.6 into the derivative of this is given by 0.6 into x to the power 0.6 minus 1. Okay, now taking common 0.6 from the upper portion by this is 1 plus x raised to 0.6 to the power 2, and this term is given by 1 plus x to the power 0.6. This is 1 plus x to the power minus 0.4. So we write here this is 1 plus x to the power 0.4, and from here we get the term 1.x raised to 0.6 by this is x to the power 0.4, because this is x to the power minus 0.4. Now if we get the LCM of these two terms, we get the result as 0.6 by 1 plus x raised to 0.6 to the power 2 into this is 1 plus x raised to 0.4 into x raised to 0.4, and this into this is given by this is x to the power 0.4 plus x to the power 1, because x to the power 0.6 into x to the power 0.4, so x to the power 1, this is x, and from here we get 1 plus x to the power 0.6 plus 0.4, so this is to the power 1. Now if we open this bracket, then this is obviously negative, so x and x cancel out, so we get the result as 0.6 by this is 1 plus x raised to 0.6 whole square into 1 plus x raised to 0.4 into x raised to 0.4, and in the upper portion we get this is, if we take common negative here, then 1 minus x raised to 0.4 we get. Okay, now it is given that x, this is less equal to 1 and greater equal to 0, so obviously x raised to 0.4, this is less equal to 1, clear, and since this is less equal to 1, so 1 minus x raised to 0.4, this is obviously is greater equal to 0. Okay, and since there is a negative sign is present, so this is negative, and which is given by less equal to 0. Okay, so we get that f dash x, this is less equal to 0 for all x belongs 0, 1. This is the given interval. So we say that from this result fx is decreasing decreasing in 0, 1, right? Now if we try to draw a curve which is decreasing in 0, 1, let this is the x-axis and this is the y-axis. Clearly this is 0 and this is 1. And since fx is decreasing here, so the curve must be like this. Okay, must be like this. This is decreasing. So we get the maximum value of fx at the point 0, and if we draw like this, and the minimum value of fx, this is f of 1. So max value is f of 0 and min value is f of 1. Now we have to find the value of f of 0 and value of f of 1. Okay, and f of 0, this means capital K. This is the maximum value, capital K, and this is small k, right? And clearly f of 0, if we put here x equal to 0, then we get this is clearly 1, because x equal to 0 and x equal to 0, then 1 by 1. And if we put here x equal to 1, then we get the value of small k. This is 2 to the power 0.6 by 1 plus 1. So 2 to the power 0.6 by 2, and it is obviously 2 to the power minus 0.4. So the value of small k and value of capital K we get from these two results, and the order pair small k comma capital K is obviously 2 to the power minus 0.4 comma 1, and this is option number D. Okay, very interesting problem from maximum minimum, and we use here the property of increasing or decreasing function, right? Thank you for watching.